Ooh, look at this. Okay, so let's see. A person's pushing. So finally we've got like forces and stuff, right? Okay. Now the key for this force is if it speeds you up, it goes on the left side. And if it's a frictional force, then it's like where the energy goes to, right? So it slows you down. Okay. Now, by the way, we could figure out the acceleration of this 53, right? The acceleration would be 53 divided by 350, right? We've got the initial velocity. We could figure out using kinematics what the final velocity is, right? But that would take all the fun out of it, right? Okay. So let's do it using energy, okay? Now, notice that this track here is level, so potential energy is not a factor. Potential energy only comes in if you're going up a hill. And since the potential energy here is the same as the potential energy at the end, right, that's not a factor, okay? There is a force that speeds us up, so we definitely have a force times the distance. Notice it's also moving to begin with. So we definitely have this and this. There's not a mention of a force slowing us down. So I think all of that total energy here, the work we do plus the energy it already has, turns into the kinetic energy. So let's set that up. Okay. So 53 is our force. 35, dyslexics beware, is our distance, right? And then it's also moving, right? So 1/2 350 times 4.6 squared. And then that's going to be 1/2 350 times v squared. Okay. Now I'm going to take this whole left side and I'm just going to do it all in one swell foop. Okay. Are you ready for this? Nothing really prepares you for this. Okay, so 53 times 35 plus 0.5 times 350 times 4.6 squared. I'm too lazy to do this in more than one step. So 558 joules is the entire left side. Okay, and then that equals 1/2 350 v squared, right? Okay, so let's do this. This guy times 2 divided by 350 gives us v squared. So 31.76 is v squared. So therefore v is equal to, so I'm going to go second square root, second answer, 5.635. Now, let's imagine that you hadn't studied conservation of energy. How would you do this? By the way, now is a good time to stop because I'm just going to go off on a rant. Okay. If you didn't have this, right, let's imagine that we didn't use this. I could figure out the acceleration. That is, 53 newtons, supposedly unopposed, right, over 350. So our acceleration is gradual. 53 divided by 350 is 0.1514 meters per second squared, right? And now I could get the final velocity using this. Vf squared is vi squared plus 2ax. Okay, so v final squared is equal to 4.6 squared plus 2 times 0.1514. Okay, times, and then our x is 35 meters, right? Okay, so let's do this. Let's see, 4.6 squared plus 2 times that answer I just got times 35. And then I'm going to raise that to the 0.5, and I get exactly the same answer. Okay? Only, really, this was 2 steps. I had to do this, and then I had to do this. We did it in 1 step with energy. So energy's the way to go, even, I don't know. That's what I think.